Okay, good day everyone. This is Professor Roger Flores of the Department of Electrical Engineering, Central Mindanao University. The professor of this subject, EE86, the high-rise building design. Definitely for this subject, this is for the to discuss the how you are going to design electrical plan and electrical system for a high-rise building. So the chapter 1 of our subject is this electrical system design for high-rise building. Here we are going to discuss some insights, ideas on how you are going to design the high-rise building. No? So talking about high-rise building, we have different types of high-rise building. You have the complex building, or commercial complex, or residential condominiums, or even high scraper, or a combination of commercial and residential building. Okay, so to start with, let us discuss this chapter 1. It is entitled Electrical System Design for High-Rise Building. Okay, so this is just the insight of the insight of our subject, no, to give us some insights in designing electrical system for this high-rise building. Okay, let's proceed to emergency power system. Okay, so mayroon tayong tinatawag na emergency power system. In case of blackouts or brownouts, then we have this emergency power system. The power requirements of the building can be sufficiently supplied by the power company at acceptable level, continuity, and characteristics. However, instances when the power may be interrupted due to the system fault or deficiencies, some of which are inherent in the power transmission and distribution of the distribution utilities. No? Longer interruptions will create inconvenience with the building occupants and even the dangerous to life and limbs. No? So baka mayroon tayong mahulog dyan kasi masyadong madilim, kasi brown out. So we need to have this emergency power system. Okay, losses in terms of unproductive man hours and business opportunity may also substantial. Okay, so wala na magagawa yung mga tao kasi brown out. So we need to have this power supply. The suggested solution, other than the self-contained battery-powered emergency lights, is a standby diesel engine generator sets. No? It is not economically sound and probably poor engineering practice to provide 100% backup for standby power because of the tremendous cost of generator sets or sets to be in the relatively short time of main power interruptions. Now, some of the establishments will not supply all the or 100% sa load, no? So but in our design later, because we are thinking of having a complex design or a combination of commercial offices and residential like condominiums, then it's better to think in advance that our design should be supplied by 100% emergency power system. Okay, ibig sabihin, the whole building will be supplied by the emergency power systems or the standby generator. Okay, so mahirap naman yung we have to choose kung sino lang yung supplyan natin. So halimbawa, yung mga occupants natin sa mga condominiums natin, so we should have to consider 100% emergency power system. Okay? So, the more essential loads of the building are to be supplied with emergency power. Yun po ang karamihan, no? Yun lang mga essential na mga load lang yung supplyan natin ng emergency power, no? So, normally these are the following. Yan, pag hindi lahat, no? Pag hindi lahat yung supplyan natin, ang pinaka-importante kailangan yung stairways, yung mga hagdanan, saka mga hallways, kailangan mayroon tayong mga lighting, no? And then counter areas for public transactions. Like for example, yung sa mga cashiers, no? Sa mga cashier areas or sa manager or sa mga yung mga hindi pwedeng ma-brownoutan, no? So kailangan natin ng emergency power supply, yun ang uunahin natin. Power pumps and fire pumps. This is very important. Why? Because baka pag dahilan sa brownout mayroong sunog. So paano natin gagamitin yung mga fire suppressants natin, yung pag walang pumps, pag walang kuryente. So kailangan natin ng separate power supply para sa mga fire pumps, no? Or water pumps. 1 or 2 elevators to be used for physically handicapped. Okay. So karamihan ng mga building pag mag-brown out, i-disable nila yung mga elevators, pero hindi suggestion natin, hindi lahat na elevators i-disable natin. Kailangan kahit isa, yun na suggestion, kahit isa o dalawa, para for those who are physically handicapped, yung mga PWDs, no? So doon sila dadaan. Mahirap naman na idaan natin sila sa may hagdanan, no? Sa mga exit doors or exit stairways, no? So we should have to allocate maybe 1 or 2 elevators to transport these PWDs, no? Then also for the computer system, especially that will handle sensors, no? So we should have to supply also emergency power on that, or rooms or suites of top executives. Okay, so that's very important also. Yung may-ari ng building at saka yung mga top executives natin, kailangan na supplyan din natin sila para hindi magagagalit. Okay, so class, these are the things that we're going to supply emergency power in case of failure of the power utilities. Pero ang pinaka suggestion ko po, lalo na dito sa i-design natin, we should have to design our electrical design, whatever buildings or high-rise building that you are going to design, 100% sa load niya. Okay, so mayroon tayong sinasabing power system, no? Emergency power system. Because of that, we have also to consider ATS, or mayroon tayong automatic transfer switch. Okay, so usually ginagamitan lang natin ng manual, pero ang problema pag mayroon tayong manual, mahirapan tayo mag-transfer from generator to the load. Okay, or go back to the power utility, no? Pag mayroon tayong manual na double throw lang gagamitin natin na transfer switch. Basically, we should have to use automatic transfer switch. Kasi alam niyo, yung automatic transfer switch, pag magba-brown out tayo, under diretso na yon, under yung generator natin, tsaka for a few seconds, then mag-supply na yan sa mga load natin. If you are using automatic transfer switch, it will not take several minutes, no? It will not take several minutes. Siguro, as mga 3 hanggang 5 minuto. Kasi pag manual transfer switch natin, ay nako, haba pa yon, siguro mga 10 to 15 minutes bago mag-under yung emergency power natin. So especially yung malalaking mga generators, lalo na't nag-supply tayo sa air conditioning system, malalaki yung air conditioning system, then we should have to if you are going to it is more advisable to use this ATS or automatic transfer switch. Ang worries lang po doon sa iba, na nag-worry silang gumamit ng ATS, baka halimbawa daw holiday or weekend, na paano pag mag-brown out, under yung generator, wala nang papatay dyan sa generator pagka bumalik na yung distribution utility. Hindi po yun. Mayroon tayo mga ATS na automatic din. It will automatically tick off, no? Pag bumalik na yung kuryente or power natin doon sa utility. So hindi na kailangan tao pa yung papatay doon sa linya. Siya na, automatic na niyang mag-off, no? For the latter, or in other words, for that ATS, it is necessary that the feeder or line serving the essential loads should not include the non-essential facilities. Separate emergency lines and panel boards will be provided exclusively for the purpose. Okay, so that is if we will not supply the whole system. Pero yun ang sabi ko kanina, yung sa design natin na condominiums na high-rise building, kailangan 100% ng supplyan natin. Okay, so this is the typical standby power system illustration or single line diagram. Okay, mayroon tayong dalawang transformer dito po. Supply transformer or transformer 1 having 460, and we have transformer 2, we have 460 also volts, and then this will supply this load here, and the other one, this will supply the other load here, no? So yan sinasabi dito, emergency load feeders, yung mga load na kailangang susuplayan ng energy. Okay, so mayroon tayong dalawang ATS or automatic transfer switch. We have this generator. Okay, standby generator. It is a set or sets, no? Malalaki or lahat na load natin ang yung susuplayan natin. So, kailangan more than one. Pwede. So, mayroon din tayong engine dito. Ito po yung prime mover to supply mechanical power to this generator to generate, no? Or so we have the disconnecting means. So we have all this. This is just a simple illustration of using standby generator and the utility power supply. Dalawa po dito. Dito siya dadaan ng automatic transfer switch. Yung automatic transfer switch natin naka-set up na yan, no? Mayroon yang setting, ilang minuto lang ba? 3 to 5 seconds. Pag mag-brown out, pag wala ng load, mag-brown out, andar yung generator natin. Hindi naman pwede na pag andar ng generator, nakakonect siya diretso sa load natin. Baka ma-overload yan, no? Lalo na't self-excited generator yung generator natin. So, kailangan we have to have a few seconds to delay, no? To saturate first the output of our generator, no? So, dito sa generator natin. So halimbawa saturated na saturate na siya. So ibig sabihin normal na yung voltahe niya dito bago pa ito transfer itong automatic transfer switch. Anyway, this is just in a few seconds lang. Mangyayari na yan, no? So ayun, in a few seconds delayed, no, after the operation of this generator, transfer na niya yan, no? Pag bumalik na itong utility natin, automatic din yung transfer switch natin. Bago niya i-disconnect yung generator natin, i-connect niya muna itong local utility, distribution utility. So pasok ito agad, no? Pag bumalik ito, pasok ito agad. Pagkatapos, ilang sandali, papatayin niya itong generator natin. Automatically, siya na yung mag-off ng generator. Ayun ang mga bagong ATS. Pero kahit mayroon na tayong mga automatic transfer switch, kahit itong transfer switch natin automatic, mayroon din itong mode na manual. Ibig sabihin, kahit tayo lang ang mag-transfer, pwede pa rin, no? Manual yung transfer natin. Mayroon din itong mode na separate mode na manual. Okay? So this system operates as follows. Yung pag gumamit tayo ng transfer switch, no? Unang-una, when main power voltage dips to 70 to 80%. So ibig sabihin bumaba yung line voltage natin na from 70 to 80%, or lalo na pag mo-brown out, zero yan kaagad, 100%, bumaba na yan, patay diretso yung linya. The ATS automatically starts, no, the generator and build up same to its rated output voltage. Ayun. Pag bababa na yung rated power natin galing sa utility ng 70 to 80%, automatic aandar na yung generator natin. Okay, pero hindi yan automatic, ha. It will take 20 seconds. Okay, so this is the basic setting, no, 20 seconds. Pero mayroon pa dito mga ATS na or mga generators na kahit hindi pa abot ng 20 seconds, no, diretso na kahit 10 seconds lang. Okay, so automatic yan, no. The ETS automatically transfer the emergency feeder means the generator. When main power is restored, its rated level, the ETS instantly transfer. Hindi na yan naabot ng ilang segundo, automatic na yan, transfer yan agad. Okay? So pag bumalik na yung local distribution utility natin, pag mayroon ng power, then automatic agad na yon, agad-agad na yon, no? The load back to the main power feeder. After 1 to 2 minutes of main power stabilized condition, the generator set automatically stops. So ito po yung mga ETS natin ngayon, okay? So bakit hindi agad-agad papatayin ng ETS yung generator? Una-una, that is a machine. It is the work of the mechanical engineer. But anyway, just to give you an idea, hindi niya agad-agad papatayin kasi baka unang-una, baka mag-off na naman ulit, no? Diba? You might experience, no, na galing brownout, naka-on na yung linya, ilang sandali lang, naka-off na naman ulit, no? So it will become burden to our generator na wala na siyang load kasi bumalik na, na-disconnect na siya. Okay, so hindi yan papatayin agad kasi baka mag-off na naman ulit. Okay? So para bang tao na mayroong load dito sa niya, sa may likod niya, tsaka kinuha natin yung load abruptly. Ngayon medyo nakarelax siya, tsaka lagyan na naman natin ulit ng load accidentally. So mahirapan yung generator pag ganyan. So ibig sabihin, yun ang dahilan, no, na kailangan natin na hindi agad-agad papatayin yung generator. Pangalawa, mechanically speaking, yung generator natin siguro mainit pa yung mga piston niya doon sa loob ng makina. So kailangan natin na medyo ipalamig muna natin, no, by running this machine without load. So running idle, no, idle yung takbo niya para wala naman siyang load. So nag-andar siya, na gumagana siya, nag-andar na walang load. So it will take few minutes for few seconds, no, na medyo palamigin niya yung component lahat doon sa loob ng makina. Okay? So the ETS could also be programmed to automatically exercise or operate the generator at no load for 15 minutes, twice a week periods in order to keep the set and auxiliaries in good running conditions. Okay, so this is one of the problem in having this standby generator, no? Kasi mahirap and it is very expensive for the fuel if you're going to run this generator kahit walang brownout. Pero disadvantage dyan, baka pag hindi mo yan ipinaandar for ilang weeks or siguro ilang buwan, no, na walang brownout, so baka ma-discharge na yung battery niyan, o baka mayroon na yung oil dyan sa makina niya, baka nakasettle down na, mahirapan yan pag andar na yan ulit. Okay? So, in other words, it is suggested that from time to time, siguro once a week, kahit walang brownout, we should have to let our generator run. Okay? Kahit walang brownout, kahit walang load, basta ipaandar natin yan para more or less ma-charge yung battery niya, yung ibang mga oil niya, di-distribute na naman ulit dyan sa mga component dyan sa loob ng makina. Okay? So, voltage level and time setting, as mentioned, may be adjusted to the desired level of the user, but instant transfer from main to standby power is not possible since it will require some time for the generator voltage to build up. Okay, so yun, especially if our generator, which is usually yung generator natin is self-excited shunt generator. Okay, so next, for uninterruptible power supply, as may be required by the computer hardwares and the like, different equipment configuration is necessary, no? It discussed in the succeeding paragraphs. Okay. So, halimbawa, yung computer natin, kailangan na mayroon tayong uninterruptible kasi sabi natin kanina, yung ETS, yung generator natin, hindi yan na makapag-supply agad-agad. So, we need to have this UPS or uninterruptible power supply. for computers and any other, halimbawa sa hospitals na baka nag-oopera yung mga doctors na tsaka nag-burnout, baka madisgrasya pa yung pasyente, so kailangan natin ng emergency power so doon sa laboratory rooms, no? Okay, so for power supply, computer hardwares and operations requires controlled environment as to temperature, humidity, and dust for satisfactory performance. The same is true for its electric power supply. Power hits and dips, no, which is normal occurrences in easy power systems, are sometimes beyond the tolerable limits of the computer. Some hardwares cannot tolerate power disturbance of more than 1/5 of a cycle, no? So, of the normal 60 Hz. Pag baba ng yung normal na operation ng frequency niya, baka masira pa yon. While specially designed automatic voltage transfer or AVR may serve the purpose, the automatic voltage regulators may be used, no? The problem will be in the response to time correct the abnormalities, not to mention actual power interruptions. Okay. So, on power interruptions, the time lag for the emergency generator to build up, okay, yun po mga ilang minuto na pag-build up, okay, and supply power through ETS is away beyond the recovery time of the computer. So, may hirapan tayo hindi yan diretso, no? Computer will shut down and have to be reset and restarted. Now, paano kung kailangan agad-agad, no? So, we should have to put this what we call as uninterruptible power supply. Okay. So, as recommended, condition power system for computer is the uninterruptible power supply. Ayun. Okay, so ito po yung simple block diagram, no? As suggested. Mayroon tayong AC source dito. Mayroon tayong RCB dito. Okay? So, yun po. Mayroon tayong rectifier charges dito or charger para ma-charge itong battery natin from time to time pag tatakbo ito. Then we have this DC, no? So, we have this inverter that convert AC to DC. That is inverter here. Or from DC to AC, yes, your battery. Okay, halimbawa ngayon, it will run here. So, mag-charge yung battery. Pag mayroong interruptions, ito ng battery yung mag-supply doon sa ating mga computers. So, bago yan, mayroon tayong inverter dito that inverts the DC output of the battery to AC, no? We have also the circuit breaker here to protect and all the system. Now, actually, we have this bypass line here. Ano ba itong bypass line? That is if we have a normal conditions na hindi natin kailangan natin yung uninterruptible power supply. Tuloy tayo dito sa rectifier charger. Ano ba itong rectifier charger, no? So, feed the emergency feeder through RCB breaker. Okay, supplies the DC bus. The battery is charged and at the same time supplies power to the inverter where DC power is inverter to AC, no, or inverted to AC. Output of the computer load. Charging of the battery is appropriately controlled. Okay, yun na, sabi ko kanina. The output feeder line to the computer is protected by the inverter circuit breaker or ICB. The inverter circuit breaker, no? In case of power supply and system infirmities, hits and dips will not be reflected in the AC output lines as this is absorbed in the rectifier or the charger only. Okay, so in other words, kahit mayroon tayong mga dips or low voltages, no, mayroon tayong pagbaba ng voltahe, hindi ito ma-experience ng computer natin kasi dadaan pa yan doon sa mga ICVs natin or doon sa itong tinatawag natin na inverter, no? So, kahit mayroon tayong mga low voltages dito, mayroon naman tayong inverter na siya na lang po bahala dito mag-supply ng regular or equivalent voltage, no? So, when power is interrupted, the floating battery will supply DC, okay, bus, such that the inverter will not suffer any power stoppage, no? The battery bank is normally rated to supply power up to 10 to 15 minutes Okay, so ibig sabihin, so if the UPS or the battery bank will supply 10 to 15 minutes, ibig sabihin tamang-tama nandyan na po yung generator natin. Nakatakbo na yung generator natin, naka-andar na yon. So sabi natin kanina mga 3 to 5 minutes lang mag-supply mag-supply na yung yung generator natin. So ibig sabihin bago maubos yung power supply na-store natin sa ating battery bank, so hindi pa maubos yung bank natin, battery bank, then nandoon na yung standby generator natin, no? So time enough to build up and put in the line the emergency generator. The battery bank composed of 100 to 150 industrial type heavy duty units. Hindi yung battery bank ng cellphone na ilang charge lang, dalawang charge ay lubat na. Okay, so up to 2 to 2 and 1/2 volts per higher capacity units. Okay. So in the UPS so when that UPS itself fills, the static transfer switch or SS, no, static transfer switch will automatically transfer the output to the bypass line. The transformer is of the make before break, no, make before break, no. So make before siya break or to disconnect the whole system, then the AC output will not detect, no, the switch mode. Manual transfer to the bypass line can also be made through the commercial circuit breaker or CCB, commercial circuit breaker. There are several supplies of the imported and locally manufactured UPS. Okay, just be sure of the material that you're going to use. Rotary type of combination of an AC motor, driven alternator, and standby diesel power, no? So with a flywheel is another configuration. We have this one, no? So ibig sabihin, we have this diesel engine. Mayroon tayong tinatawag na flywheel dito para more or less while on normal operation, ang AC input niya dito at saka mag-brown out, tuloy-tuloy pa kasi mayroon tayong flywheel dito, no? So dahil dito sa flywheel, tuloy-tuloy yung takbo niya, so it will still generate power towards this generator. So ito pong diesel engine natin, pang start up lang to. Okay, so ito po yung schematic diagram of dynamic UPS system. Number 5, we have to discuss next the feeder number of sizes, no? Feeder line can either be busway or insulated conductors. Ito po yung pinaka-main connection or cable, no? So it can carry up to 7,000 amperes and then 450 amperes maximum per set, no? Then busways, however, could be highly corrosive atmospheres as in battery rooms, no? So we have here, there's no limit placed in determining the number of feeders, its maximum load, and hence its corresponding circuit protection. So ibig sabihin, every design that we have, we cannot limit if it is necessary or required by the installation. But of course, it has an equivalent protection and that fit and protect the system for overloading and any other short circuits. Okay, so we have this simple power distribution system using plug-in system lang po to. Ito po yung mga bus bars natin. Ito po yung mga pinaka-main breakers natin, main power. Mayroon tayong mga bus bars, no? Marami tayong mga bars. Tinatawag po itong plug-in busway because tanggal-tanggal po ito, naka-connect po ito. So, pwede makakonect or matanggal natin. So ito po yung tinatawag natin na busway. Okay, that is a simple illustration of this what we call as power distribution system using yung plug-in busway. Okay, consideration of design of feeders and protection. Number 1, ito pong flexibility, no? Dapat flexible tayo. From time to time, kailangan natin na magdagdag or so on and so forth, no? While a single feeder may sufficient supply several areas or floors or loads, so the scope of its effects in case of breakdown. Okay, For the general lighting and power system of high-rise building, some designer distribute the loads among several feeders. Halimbawa, yung feeder 1, kasi we have several feeders, no, or yung tinatawag natin na busway or bus bars, no. So halimbawa, feeder 1 to serve ground 3 and 5 floors. Feeder 2 serves basement and 4th floor. Halimbawa, feeder 3 serves 6th floor, 8, 10, and so on and so forth, no. So there is what we call yung sinasabi natin na intervals, no. Para more or less naman, pag mayroon tayong problema sa ibang feeder, halimbawa, magka-problema tayo sa feeder to, for example, hindi lahat yung building na medyo mag-brown out lahat, no. So we have a selected area that could be affected also, no. The idea is to minimize areas affected by the single feeder breakdown. Halimbawa, pag single feeder lang yan, ay pag mayroon tayong problema sa system, lahat na yan, brownout or blackout ang mangyayari, no. The same principle could be adapted for air conditioning, elevators, pumps, and other motor loads. Okay, next we have this conveniently available sizes of busways or conductors. While multiple busways of conductors can be used to meet desired current carrying capacity of the line, there should be some limit to this multiplicity for practical purpose in handling where building spaces are restricted. For example, 3 or more sets of large size conductors can be conveniently terminated a single receiving or originating lugs or breaker terminal. So, distributed yung ang system natin. Minimize number of replacement breakers in stock to reduce inventory carrying cost. A set of feeder breakers, say 10 units of 1,000 amperes. It's another set of 10 units of 500 and so on and so forth. Hindi yung pag bumili tayo, lahat na lang ito 1,000, ito 5,500. So kailangan hindi paramihin kasi baka hindi tayo palaging masiraan ng mga breakers. Sayang, mahal yun yung 500 amperes, mahal yun. Several thousand yan, no? Thousands yan. Tsaka yung 1,000 amperes, lalo na yan, malaki, masyadong malaki. So mas mahal yan. So we should have to buy only few. Okay, mga 10. Pero alam niyo na, marami na yung 10 kahit 5 lang. Kasi hindi naman palagi masisira yan Okay? So, allowable voltage drops in the conductors. Okay, yun po, sabi natin, the voltage drop not exceeding 3% of the farthest outlet of the power. Yung pinaka-huli doon, ano ba yan? Sa pinakamalayo, no? Kailangan yung voltage drop natin doon is not less than 3% or not exceeding, not exceeding 3% of the voltage drops. Okay, so yun ang how you're going to, then you have to try to compute, no? So while or both feeder and branch circuits to the farthest outlet, the allowable voltage drop not exceeding 5% to provide reasonable efficiency of operations. Okay, so sa mga branch circuits natin. Okay, the sizes of feeder and branch circuit wires are based on the connected load. Okay, the following can be used as preference for the purpose. Branch circuit wires of the lighting, heating, and similar loads should have a capacity not less than 125% of the load. Okay, and then 150%. Yun po yung sa current protection natin. Yung sa circuit breakers, 150% of the rating of the load, no? It is considered good engineering practice if the capacity of the conductors is not less than 150% of the load supplied. For motors, owing to its starting current and occasional overload runs, the sizes shall be computed as follows. Okay. So ito po yung competition ng mga conductor at saka yung mga protection natin. Unang-una, for the single motor load, yung isa lang yung motor natin. Size of conductor, 125% of the motor followed amperes. Followed amperes, followed current, yun ang i-multiply natin ng 125% or increase that to 25% from the followed current. Size of circuit breaker protection. So, M% times motor followed. Yun ang sa protection natin. Kung ilan ba yung current natin, then multiply it to the 25%, where multiplier in percent values depends on the type of or class of the motor. Iba-iba kasi yung multiplier natin dito pag iba-iba kasi klaseng motor na we have in the system. So 250 to 300% for smaller motors less than 7 and 1/2 horsepower with a full load voltage or across the line starters, or 150 to 200% for bigger motors with reduced voltage Y delta or auto transformer starters. Halimbawa, mayroon tayo dito. Okay, so halimbawa 150 horsepower, 3-phase, 440 volts, squirrel cage induction motor with auto transformer starter and full load ampere draw of 180 ampere current. Okay, so this is our current, no? So 180 ampere. So to determine the conductor size, 125% of that 180, we have that 125. So hanap tayo ng conductor. This conductor that could accommodate to 225 amperes. So we have this 3-phase kasi. So we have this 3 125 mm squared. The capacity of the 125 mm squared or 250 mm THW copper wire, okay? Or at 225 amperes capacity. And 65 mm diameter, okay, of the use the 65 mm or 2 1/2 inch to rigid metal conduit or RMC, rigid metal conduit RMC for this size of this conductor. Next that we are going to do is to compute or determine the breaker setting or for protection. Okay, so anong gagawin natin? We have that 150% of the current rating, followed current rating of our motor, no, 180. So 150% of that 180, more or less 270 amperes, no? So okay, yun, 270. So we have to use 270. Wala namang 270 amperes, pero mayroon tayong 300 ampere trip. So pag wala tayo dito sa 270, hindi yan pwede bababa tayo. Baka sabihin natin, mayroon naman tayong 250, but hindi 250 yung gagamitin natin. Wag po. Kasi it's better to use more than that of this computed current. So we can use 300. It is available in the market, or 400 ampere fuse if you are using fuse, no? 3-phase 500 volt circuit breaker. So we have these specifications. So this is from the tables. It shows the approximate size of conductors and circuit protection for different sizes of electric motors. Note that the equivalent rating for such safety switch is slightly higher than those of the circuit breakers. Okay, that is the difference between using fuse and using circuit breakers. Now, if we have this group of motor and other loads, take note that we have several motors. We have the jockey pumps that will be used for fire suppressants, yung ginagamit natin na pang pump sa pag mayroong sunog. Okay, or mayroon tayong mga water pumps para to inject water in the basements and from other sewerage, no? Okay, so marami tayong mga motors. So pag we have a group of these motors, this is how you are going to specify the size of the conductor and the size of the breaker setting. Okay, so given a group of motors, whether it's corresponding full load ampere or FLA, the other loads being supplied by several feeders, referring to the figure, provide the appropriate size of the main feeder, conductor, and rating of circuit breaker for protection. Assume 3-phase, 460 volts, 60 hertz supply. Okay. So makita natin dito, no, mayroon tayong 500 ampere trip. Tsaka mayroon tayong mga motors na 50 hertz, 20 not hertz, 50 horsepower, mayroon tayong 20 horsepower, another 20 horsepower, mayroon pa tayong transformer dito, 75 kVA for our lighting and other convenience outlets, no? So we have to determine the size of the main breaker for this, no? So dito sa baba, we have also a group of motors here. We have 150, 20, and 10 horsepower. Okay, so out of these competitions, we have this breaker settings here, no, group of motors. Paano ba ito mag-determine ng yung sa main feeder natin at saka sa main breaker setting? Paano ba ito? Ito yung gagawin natin. Unang-una, to determine the size of the conductor, again, we have a 100% full load ampere of the highest rated motor. Okay, tignan natin kung saan ba doon ang pinakamalaki na rating ng motor natin. Okay, so 125% yung pinaka-highest rated na mga motor. Okay. And then current of the other loads, no? Plus full load rating of the other loads, no? And then times the demand factor. Mayroon naman tayong demand factor eh. So titingnan natin dito sa mga motor natin. Okay, itong una dito, yung pinakamalaki na load dito, ito po 180 amperes, no? 150 horsepower. So mayroon tayong 180 amperes, pinakamalaki. We have this 27, 14 amperes, 65 amperes. We have 27 amperes and another 27 amperes. So we have this, yung 180 yun, ang multiply natin ng 125%. Plus sum up natin yung 27, mayroon 14, mayroon 16, mayroon 27. Tsaka mayroon sa transformer natin, mayroon 75% 3-phase, 460. So yun, lahat-lahat i-multiply natin ng 80% na demand factor, no? So makita natin ito sa Philippine Electrical Code na mayroon tayong demand factor na 80%. Okay, ito pong lahat, no? 125% of 180, yung rated current at yung sa transformer din, lahat-lahat i-multiply natin ang demand factor na 80%. Okay. So more or less we were able to determine 383 amperes na mean. Okay, so wala namang 383 pero mayroon tayong mayroon tayong conductor na can handle 383 amperes. Ito po yung 400 mm squared. Okay. Ang rated power niya, rated current capacity ng 400 mm squared is 485. So okay na yan. Kaya na niya yung 383 amperes. Okay, kasi 485 yung kaya niya. So 400. Huwag naman natin mag-specify ng medyo maliit pa dito. Baka below pa ito sa sa 383 yung makakaya niya. So we have this capacity. We have this 400 mm squared at saka gagamitan natin ng 100 mm diameter na rigid metal conduit. Okay, next, 325 mm is 700 mcm, no? Where the 425 ampere capacity may be sufficient, but the next bigger wire is chosen to allow for future growth. Okay, yun lang pong purpose natin, but hindi 425 yung ginagamit. Okay. So hindi yung ginagamit natin na mas maliit, no? Na capacity, kayang-kaya pa naman niya sana. Okay, so this is for future growth or growth of the load. Voltage drops should also be computed to determine the propriety of the selected size of the conductors. Ayun na po, we should have to determine the voltage drop o baka more than that of 5% or 3% of the voltage drops that is our allowable, no? Okay, so next we have to determine the circuit breaker, highest motor breaker, and then protection, and then demand factor. Okay, so we have this 300 amperes. Okay, so we have yun, di ba? 300 yun eh. So lahat-lahat na yun, no? 300 amperes. Okay, so 300 amperes. Then yung 27 mga load saka yung transformer. So more or less we have that 500 ampere trip or 600 ampere fuse 3-phase. Okay. So the size of the feeder conductor should be maintained throughout. It should not be reduced, say it point regardless of the reduced current, no? So ibig sabihin do not use smaller or bigger size of the conductor. All the conductors should be the same for that branch circuit. Okay, the exceptions are for runs not exceeding 25 feet and within sight, provided that the reduced line capacity is not less than 1/3 of the main capacity. Now, let's proceed to load center, panel, boards, and switchgears. Dito po na, we have to determine the load center. So, what are the necessary design that you are going to do in that load center? So, ideally, load centers and panel boards should be located on the center of the load to be served, to save on wire runs and to minimize the voltage drops. However, most of the time, that is designing architect for aesthetic purposes, the final decision of the matter. So basically, we should have to locate our load center. Yan nga po ay tinatawag natin na load center kasi kung saan natin makikita yung pinakamalaki yung load, then try to determine saan po yung sentro ng load natin, doon sana ilagay natin yung mga load centers natin. Okay, so the electrical engineer should, however, strive to locate the panel boards at point where the farthest load to be served is within 30 meters. Okay, so dapat yung farthest load natin is within 30 meters. Otherwise, more than 30 meters, baka more than 3 or 5% na yung drop natin. Panel boards, switchboards, and switchgears. In general, panel boards and switchgears are used as control protection points for groups of feeders or branch circuits serving the electrical loads in building area, usually floor or a section of the floor. Panel board consists of a metal enclosure containing bus bars to which circuit breakers or fuse switches are attached. The interior space of the housing provides sufficient physical space for installation, okay, for additional also. Okay, they are they are generally classified into two categories: lighting and appliance panels, and then power distribution panels or PDP. Okay, panel board mounting of power motor starter units may be also involved. Okay, so yan po ang PDP or power distribution panel. What is a switchboard or a switchgear? On the other hand, are freestanding assemblies of switches, fuses, and circuit breakers, no? So, which serves as location for larger devices. So, ito po yung mga assembly ng switches and fuses and other circuit breakers to protect our system. Yun po tinatawag natin na switchboards and switchgears, no? So, the panel board itself is just a panel board, and that is the cabinet where you're going to attach these switchgears or switchboards, no? Switchboards are physically larger than panel boards due to the size of the overcurrent devices involved and are designed to provide necessary space of installation. Okay, there is no clear distinction between the two, switchboards and switchgears. Anyway, yun po yung assembly ng mga protection natin, no? Is referred to as switchgears, no? When molded case breakers are utilized in a switchboard, it is often known as building type switchboard. Main metal enclosed switchgear for commercial, industrial, and public buildings, okay, is invariably located in the basement and housed in separate well-ventilated and electrical switchgears rooms. Other types of metal enclosed switchgears, metal clad, compartment, or compartmented, okay, or cubicle, okay. So, yun po yung mga klase-klase na, no, mga switchgears at saka switchboards. Okay, so this is just simple illustration of the panel boards and the panel boards construction. So, dito po yung mga main breakers, yun ang mga branch circuit breakers, and the rest of the load. Okay, so ito po yung panel board, no? Yung metal enclosures. Okay, so ito po yung mga switchboard at saka switchgears. Dami dito sa loob. Okay, dito, it is a switchboard. Kaya ito po yung mga detalye na dito sa mga loob dito ng mga panel dito. Okay, so suggested steps in building wiring design: prepare an electrical load estimate, no? So gawa muna tayo ng design, saka yung estimate, yung design natin, gawa natin in areas of the building and other pertinent data for office buildings. Philippine Electrical Code has information on the estimated general illumination for lighting. Some other books can furnish the data for other loads, no? So yun po yung una, no? Or estimated load per square meter is 0.1 kilowatt or 1,100 ano ba yan? 100 watt, no? Per square meter of habitable area and may be used to counter check the estimated load. Okay, so per habitable area, your estimated power per square meter is 0.1 kilowatt or 100 watts. Consult the local company as regard the point of service, entrance service, voltage metering equipment, and other requirements to power connections. Okay, determine from other designers the exact electrical rating of all equipments. Yun po, yung sa mga ventilation, yung sa air conditioning system, yung sa mga heating, no, or mga heating elements. Try to consult other engineers for this the rating of this one, or else just research. Plumbing, elevators and escalators, kitchen and others, yun po bang kailangan natin na lagyan ng mga power supply? Yun ang itanong natin, no? Determine the location, estimated sizes of the different electrical supply equipment such as load center, switchgears, and so on and so forth. Then design the lighting systems. Okay, either the lumens, point by point methods, or consult with the architect and lighting designers. Okay, mahirap yan, no? Halimbawa, yung mga classrooms, kailangan natin ng ganito kalakas yung ilaw, yung intensity of light, yung sa mga bedrooms, yung sa mga living rooms, for example, yung sa mga sinihan, for example, iba-iba yan, no? Yung sa mga stadiums or sa mga sports complex, iba-iba yung requirement natin ng intensity of light. So, you have to consult all these things per unit area, no? Okay, assign circuitry for lighting and power, and system to appropriate panels including emergency lights and computing panel loads. Okay, so next, what we are going to do, prepare riser or single line diagram to include main distribution panels, a load center, switchgears, switchboards, and others, no? Check and coordinate the other trades, architectural structure. Baka makaproblema tayo sa location natin ng mga panel boards at saka yung sa mga lighting equipments and devices. So next, okay, so this is just a typical circuit design of load calculation system. Just go over with this. Okay, so these are some of the typical molded case circuit breakers na available sa merkado. So try to review this one. This is the frame sizes. Okay, the ampere rating of the frame or the this panel board. Okay, or the trip setting of the breakers, no? So, mayroon din tayo ditong hanggang 6,000. Okay. So, typical interrupting rating or tinatawag natin na RMS, symmetrical amperes. For 240 volts, mayroon tayong 10K kiloamperes, 18 kiloamperes, so on and so forth. Ito po yung mga medyo malalaki na mga rating ng mga breaker natin or interrupting rating of the protection natin. Okay, standard ampere ratings for low voltage. So, mayroon tayong ganito. Okay? Mga ganyang rating. Okay, class. So, andito po yung mga references natin. Just read for this. By the way, yung Philippine Electrical Code natin, dapat doon tayo pupunta sa 2017 edition, ha? Mayroon na kasing bago yung 2017 edition. Yun ang gagamitin natin. Baka yung iba dito, gumamit pa ng 2012 or 2009 na yung sa Philippine Electrical Code. Okay, so yun po ang lahat-lahat na discussion natin dito. So if you learn many things, if you think that you learn many things, just try to subscribe my YouTube channel and try to share and click that notification bell, so that whenever I have a new video uploaded here, then you will be able to you will be notified. Okay, once again, thank you very much. God bless, and stay safe and stay healthy. Thank you very much.